Hello, this is a short instructional video to familiarize you with the equipment, the connections, theory of Hall effect measurements using the model 7001 scanner, model 7065 Hall effect scanner card, model 2182A nanovoltmeter, model 6485 picoammeter, and model 6221 current source. The device we're going to try to simulate is a Hall effect device, and it looks like this, a square of resistors all the way across. We're going to use 10K ohms on each resistor so that they're all the same. 10K, 10K, and 10K. The pins 1, 2, 3, and 4, those are the access pins to the device we're going to measure. The way we got it set up, it actually looks like this. We're going to source between 1 and 2. So what we have here is one resistor in parallel with 3 resistors. So these again are all 10K ohms. So if you look at it, if we were to make the measurement from 1 to 2, that's across really all of these. The actual resistance looks like this. You'd have 1 over 10,000, which is 10K, plus 1 over 30,000, or 30K. That would equal 7.5K ohms. We're going to source 100 microamps through this 10K, and it should drop 750 millivolts, or 0.75 volts. So now, let's take a look at the connections to the 7065 Hall effect card. The two types of connections here, coax and for the current monitor output. The inner 4 are 2-lug triax connectors. They connect directly to the device under test, or what we would call the Hall effect sample. With the shield off, you can see there are many components on this model 7065 Hall effect card. Here are the 4 electrometer grade buffer amplifiers, and the most important is the guard switch, which is right here. Right now it is set for the guarded position with the 2 Berg pin jumpers on the lower 4 pins. The upper 4 pins, if we were to switch over, would be the unguarded position. At another part of the card are the actual connections for the voltmeter. What we have here are the red and black leads, which would be the high impedance and low impedance leads that would go right into the voltmeter. They are just standard screw terminals where you just strip it back and lock it right in. Okay, this is the Hall effect setup here in this entire piece of equipment. Here we have a test fixture that has several square type resistors who do anywhere from 0.1 ohms up to 100 gig ohms. We're choosing low resistivity in this video for the 10K ohm. So with 10K ohms we need to set up a few things on the equipment such as follows. Okay, well let's start with the setting up of the current source. Since we're going to be going across a sample that is a 10K ohm square, which is really about 7.5K ohms, we're only going to source 100 microamps. So to do that, we just go to, see it's set to 100 milliamps here, range. We're just going to go down range until it's set to 100 milliamp range. Then we're going to input 100 microamps. Enter. So now it's set for 100 microamps. And in this particular example, we need to set the output low, or the inner shield of the current source on the triax connector, to guard. And that's very easily done on this particular machine. All you have to do is hit the triax button, look for inner shield, see it's blinking. It's blinking here, so we need to go over to guard, enter, and it's all set. That's the setup of the current source. Now we're going to set up the 7001 and 7065 Hall effect card. These are the cross points that need to be closed. We're going to select the channels of 1, 2, 1, press enter, 1, 1, 2, press enter, 1, 1, 3, enter, and 1, 2, 4, enter. And what that does is that allows us to source the current through 2 pins and measure the current at the same pins, so that we should see about 750 millivolts when we source 100 microamps through this system. This is just a test to show you how it works. So now that that's set up, all we need to do is press close, and if you watch the display, there we go, it closes the appropriate cross points. Okay, we're all set up except for the 2182A, and the default state is in the lowest range, so we want to go up a range, go into 1 volt range, because we know we're going to be measuring hundreds of millivolts. We're all set. All we have to do is press the output on for the source. We know these channels are closed here. The picoammeter is in 0 check. If we were to release 0 check, we should see 100 microamps. There it is. Also, take a look at the 2182A. It is measuring the 750 millivolts like expected. Therefore, we have everything connected and configured appropriately. Okay, we're going to set up the model 6221 current source to source 100 picoamps through the 10 gig ohm device we're using. So let's do that. We go to the range button. Go over to the appropriate, there we go, enter. So there's 100 picoamps. Now the inner shield of the triax connector on the current source must be set to guard for this sensitive measurement. So on this instrument it's very simple. All we need to do is press triax, look for inner shield, see that it's blinking, press enter, select guard, enter, exit. Now it's all set up. Now we'll set up the 7001 for the appropriate cross points for this high impedance measurement. We'll start off with 1, 2, 1, enter. 1, 1, 2, enter. 1, 1, 3, enter. 1, 2, 4, enter. And to enable the high impedance electrometer grade buffer amplifiers, we need to set 1, 4, 5, enter. Press the close button. All of the cross points are now closed. One more configuration to set up. On the 2182A, we need to just set up the appropriate range. Let's go to the 1 volt range. And now we're set. We press output on the current source. The current flows. We take through release 0 check on the 6485. Should read about 100 picoamps. Very close. And look at the 2182A, 750 millivolts. So 100 picoamps with this 10 gig ohm device, which is effectively 7.5 gig ohms, is reading 750 millivolts. That's the exact measurement we were expecting. High impedance measurements with the 7065 Hall effect measurement equipment.